trigonometry using the idea of radian measure, we get high mileage out of considering the unit circle. Now, the unit circle is a circle whose radius is 1. So here's a unit circle. Now, with radian measure, we know that theta is equal to arc length over radius. That is, if we're talking about an angle theta, a central angle of theta, then that central angle is equal to arc length over radius. But gee, if we're talking about a unit circle, then the radius is 1, and so theta corresponds with arc length. Now, so this opening of theta can be considered to be the same value as we have for the length of this arc. And I'm going to call the length of that arc t, just for the time being. All right, now consider the idea that we can take a real number line, and let's say I have a real number line in my hand right here. And let's say that, from our previous experience, the positive values lie to the right and the negative values to the left. Now look at what I'm going to do. I'm just going to take that number line and I'm going to twist it like this. And I'm going to put 0 on the number line right here on that unit circle. And now I'm going to take these positive real numbers and I'm going to wrap them around this unit circle in this direction. And I'm just going to keep on wrapping. I have an infinitely long line here with real numbers. And I'm just wrapping that line around this circle. All right, and in the negative direction as well. I'm going to take these negative real numbers and I'm just going to wrap them around this unit circle. Just wrap, 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 wrap. Okay. Now I've got a situation where I have a length of an arc. And, of course, it corresponds with an angle here. But let's forget about the angle for the moment. Let's just think about arc length. So we have an arc length, a real number, you see. And that real number is associated then with a point, because once we consider the real number t and we travel along the circle that length, you see, then we arrive at a point on the circle, and that point has coordinates, and the coordinates of that point are x, y. Now, let's associate this idea of arc length and the coordinates of that point on the unit circle with trig relationships or trig functions. Now, there are 6 trig functions: sine, cosine, tangent, cotangent, secant, cosecant. And let's define them this way. Now, sine is abbreviated as sin, cosine is cos, tangent is tan, and so on. All right, that the tangent of that real number t is simply the second component in the coordinates of that point where we land on the unit circle. So the sine of t is y. The cosine of t is x. The tangent of t is y over x. And cotangent t is x over y. Secant of t is 1 over x. Cosecant of t is 1 over y. So all of these just involve the coordinates of that point that we talked about. And also we notice that we have a reciprocal relationship between tangent and cotangent. We have a reciprocal relationship between cosine and secant. We have a reciprocal relationship between sine and cosecant. Okay, and that's kind of a handy idea as well. Okay, so now we can relate all of this back to the notion of angle. It would be okay, but we want to emphasize the idea of a real number. You see, of taking these functions of real numbers and associate them with the coordinates of points that lie on the unit circle. A really interesting twist in this study of trigonometry.